First thing to notice is that the boxes are tumbling and precessing correctly. And the second thing to notice is the performance that I am measuring down here. So it now says 1.93 microseconds. So what I'm actually measuring is the time it takes for one narrow sweep. So there is first a broad phase that checks if the boxes, bounding boxes, are colliding with each other, and if they are, that potential collision is sent to a function that do the narrow sweep, and when it enters that function it starts the timer, and when it leaves the solver it stops the function and prints it out. So that time includes the solving of the collision and the narrow phase checking. So the narrow phase checking is the check where all the corners is checked against all the planes and all the edges are checked against all the other edges. So that's a lot of checking, and still the time is less than 2 microseconds. So that I can do 500,000 narrow sweeps every second, and that part is also fully multi-threaded on a lockless queue that I made, and I'm very pleased with the lockless queue because it seems rock solid. It's multiple consumer and multiple producer. Yeah, that was an adventure. It worked. So that's fast. I don't think that will be a bottleneck, which I was afraid it would be when I started doing this, but it doesn't seem to be, so that's nice. And the checks are also continuous, so that means that fast colliders are not passing through each other no matter how fast they are, because I'm sweeping the lines and the corners and the edges and the planes against each other through to some vector mask that I did. And that means I'm calculating the actual position where the collision occurs and the actual time where it occurs, so that the collision is not checked only at the end of the frame or the beginning of the frame. It's checked all over the frame, and I take the actual collision position and the actual time. Then I solve it, and I have new velocities, angular and linear velocities for the boxes, and I continue to check for the rest of the frame. Are there any more collisions during this frame? So I can have multiple collisions on the same collider during the same frame, so I don't miss any collisions that way. And if collisions if you change trajectory so that they collide into each other after the first trajectory change, that collision will also occur. And the solver is also very accurate. I am solving with constraints if I want to. I have no constraints now, but I can have any constraints I like. Frictionless line, frictionless plane, constant rotation, stuff like that. And I also have bounds, so I can have bounds from 0 to 1, with bounds 1 being full energy conservation and 0 being more like dough colliding into each other and sticking to each other. And also the friction is from 0 to 1. And right now what's going is very low friction and full bounds, so the energy is conserved, and you can see that the boxes are moving with a constant, almost constant velocity, or the sum of the energy is conserved. But whenever I add bounds or friction, those processes drain energy from the system. It becomes heat, and I can see that if I add any bounce or any friction, over time the energy is drained and the boxes slow down. But if I don't have any friction or bounce, they continue with the same speed. So that seems reassuring that it works. And all right. So, and these algorithms are not on the internet. You can't find them. This is not GJK or anything like that, or conservative advancement. This is, I did the math from scratch on pen and paper. So that is very rewarding to succeed with that. To start with a piece of paper and just do it all from scratch. So I'm afraid you can't get these algorithms. I can't tell you what they are because I just made them on pen and paper over the however much time I spent on this. That makes me extra happy that I didn't just implement an existing algorithm. I feel I own this because I did it from scratch. So this is what I have been up to for a while now, and it's still early days. I don't have stacking and stuff like that, but so far it's looking very promising. And I have a small Vulkan renderer going so that I can draw some debug lines and some stuff. I'm gonna do more about that, but right now I'm doing the physics engine and it's going well, so I thought I would show off some of the progress. Thank you for watching. Be safe.